Welcome everyone to our webinar today on lithium-ion batteries in the off-grid solar sector. This webinar comes off the back of our white paper, which many of you will have seen in recent days. It was published in January 2021, and our goal for this session is to supply those working in the sector with a clearer understanding of the most significant issues at play when it comes to batteries. Our panelists for the day include Franziska from the German research organization Fraunhofer, and Harini, a former colleague of mine and now current battery scientist for the digital solution provider 4R Digital. Both have cutting-edge expertise on batteries and bring invaluable knowledge and lessons learned from the off-grid solar sector. Federico and I will also be chiming in with occasional morsel of knowledge. So on today's agenda, we have myself bringing a bit of an introduction to the sort of issues and around batteries in the off-grid solar sector, and sort of outlining why we're here today and what we're up to. Then we have a battery procurement and challenges section from Harini, which will give us a breakdown of some of the key issues surrounding batteries in the sector. Franziska will follow on with more of a description on the different recycling technologies and regulations around end-of-life management, particularly when it comes to batteries. We'll be looking at European regulation as well as different developing country movements there. And then Federico will finally give a call for action and summarize a lot of the sort of key elements we've discussed today. Finally, we want this to make a really interactive session, guys, so please do post your questions into the chat as we go through the plenaries, but also we will have a healthy Q&A at the end for you guys to really get interactive with our experts here today and ask as many questions as you can. So without further ado, Federico.
Hello everyone, my name is Federico Magalini. I'm the Managing Director of the UK branch of Sofis. We are a consulting company, and most of you might have already encountered us. We have been quite active in the space of end-of-life of off-grid solar products, and we are more than happy to walk you through this webinar today to explain the challenges related to lithium-ion batteries. And now over to Franziska. The floor is yours.
I work in the topic of battery recycling, currently in a project where we want to develop a database for battery materials to improve the communication along the battery value chain and to improve the recycling of batteries. And yeah, I'm happy to present you today the options of end-of-life management for the lithium-ion batteries.
Thank you, Franziska. And over to you, Harini.
Great, thank you. And hello, everyone. So my name is Harini. I'm a battery scientist by training, and I've been working in the off-grid sector for nearly 5 years now, mostly on energy storage, on batteries, whether it's from a procurement aspect or from a management aspect. So I'm currently working as an energy storage and off-grid sector consultant at the digital platform solution company 4R Digital.
Thank you very much, Harini. And a bit about me as well. I know a lot of you on the line already. My name is Alex Clark. I'm a senior consultant at Sofis, and I specialize in off-grid solar systems and carbon capture, two kind of different worlds. And today I'll be sort of looking after the webinar and helping you guys all get your questions answered from the experts on our panelists today. So, oh God, there's an enormous picture of my face to kick things off. And here's a little intro as to why we're here and why we've chosen the off-grid solar sector. Lithium batteries are all over the world in a billion different products, but we really feel like in this off-grid solar sector, batteries are critical to achieving the Sustainable Development Goals, particularly in providing energy access to all. It's a growing market, reaching $1.75 billion annual revenue in 2020, and with roughly, predicted by Gogler, sort of 120 million users of energy access, sort of off-grid solar kits, whether it's solar home systems or pico solar around the world. It's seen to be something that is a much more efficient way of providing energy access to people in rural areas in particular, than sort of waiting for a large national grid rollout. Many of you on the line are already aware of this, so I won't push that point too much. But we really see batteries as a key to further success in this sector. In many ways, the sector wouldn't exist if we hadn't had all the improvements in efficiency and costs of lithium-ion batteries in particular. And we, in this webinar today, we'll be discussing not just those past improvements, but also what improvements there could be to come. So OGS, so off-grid solar batteries, what have we got and what sort of happened to date? So commonly, you guys will know about lithium-ion and lead-acid batteries. Those are the sort of two primary batteries used in off-grid solar systems, whether it's supplying a fridge, a TV, or some sort of small pico-solar applications. In recent years, we've seen quite a huge trend away from the lead-acid batteries towards the lithium-ion batteries as the technology has improved and prices have fallen, increasing the availability of lithium-ion batteries. Also, alongside that, lithium-ion batteries have these, really great sort of environmental impacts by comparison to lead-acid batteries, and a longer lifespan, lower self-heating rates, higher capacity and power. So they really do look to be like the future battery for many of these appliances, and we'd be surprised to see lead-acid battery making any sort of real return, particularly in this sector. However, in recent years, we have seen issues emerge, and despite all the benefits I've listed here today, there's some real issues and increasing concern with the end-of-life management of lithium-ion batteries in terms of the environment and public health risks associated mostly with that inappropriate disposal. We've been doing some projects here, with CDC in particular, and some off-grid solar companies, and really trying to dig into what happens to batteries and what happens to products at end of life. And at the moment, the results are pretty concerning in different parts of sub-Saharan Africa. With that sort of problem hanging on us, I'll pass over to Harini to actually give you some more intel on the batteries themselves, and how we can sort of tackle some of these challenges that are emerging. I'll give you the power as well, Harini. You should be able to change your screen.
Great, thanks, Alex. Great, well, let's dive straight into it, if the slide moves. There we go. Great. So Alex did mention that the off-grid sector industry used to use lead-acid batteries and have been transitioning to lithium-ion batteries. But when we are talking about lithium-ion batteries, there's actually a wide range of chemistries out there. And which chemistry is used depend on the needs of the application and what parameter you're trying to optimize for. So what we have seen in the off-grid sector currently is that LFP is one of the most popular chemistry for, say, solar home systems, as safety and increased life cycle are two of the main things that people are optimizing for. And LFP, which stands for lithium iron phosphate, by the way, is a safer chemistry compared to its cobalt-based counterparts, such as LCO and MCN NCA. However, for small application like pico solar products or consumer electronics, such as smartphones or rechargeable torches, radios, LCO chemistry tend to be used. They tend to have a shorter life cycle, but these products, will have a warranty of 1 year often, or won't be used for that long. If you think about your smartphone, usually, you'd start seeing a real battery degradation after a year or two. So LCO and LFP are the two preferred chemistry, but how does the off-grid sector compare to, for example, the electric vehicle sector? So they tend to use NMC and NCA mainly, but you will also find some LFP cells in Chinese EVs. So now you might wonder why I'm talking about EVs on a webinar about the off-grid sector. Well, it's because the EV sector is very much leading the battery demand and the increase in battery production in the world. So it has been predicted that 125 million EVs will be on the road by 2030. And for example, Bloomberg New Energy Finance has also shown that prices of lithium-ion batteries has fallen down to reach in 2019, $156 per kilowatt hour, and Tesla is expected to reach the milepost of $100 per kilowatt hour by 2023. So what this milepost represents is when EVs will be truly competitive with traditional combustion engine vehicles. So now, having said that, only large-scale EV manufacturers can source batteries at such competitive prices. And by contrast, the off-grid sector, with its lower demand and lower purchase power, won't necessarily have access to these kind of prices for a long time. So, taking a look at the global battery producers, you can sort of divide them into different tiers. So, if you divide them into 3 tiers, what you'd see is that top tier might have names that you've seen before, like Tesla and Panasonic and LG Chem, and these tiers are established from the production volume, but also from the quality of manufacturing. So it's both. And these top tier battery manufacturers will tend to supply their batteries to top tier electric vehicle manufacturers. And actually there's predictions of shortage of even tier 1 batteries, despite the fact that a lot of new gigafactories are popping around the world. And tier 2 battery manufacturers are just not yet good enough for what we call tier 1 EV makers. So all of this to say that it is likely that the off-grid sector will have to work with tier 3 suppliers. And as you see here, most of them are based in China, and there's a wide range of suppliers available. And often they will have similar prices, but the quality will widely vary from supplier to supplier. And that has been one of the great challenges of the off-grid sector, to secure good quality batteries and partnerships, as it's not always easy to know who's a good supplier and who's not. Another challenge that has hit the off-grid sector is the financial stability of battery supply. So there was a report a couple of years ago that was published by the Shell Foundation, who had interviewed several solar home system manufacturers and mini-grid providers. And one of the key statement that was picked up, was said by many, was that they're worried about the stability of their battery supplier. So I thought it was worth giving you a bit of context why that was. So the Chinese battery sector has boomed and has been widely helped by this subsidy called New Energy Vehicle that was introduced back in 2015 by the Chinese government. And what it did was essentially give subsidies if Chinese EV makers were using recommended Chinese battery suppliers. But with the market being more established in 2019, they decided to allow foreign battery manufacturers to enter this market, which essentially left many tier 3 and tier 2 suppliers as well struggling. So I think the off-grid sector was hit by a knock-on effect, where they saw some of their suppliers really struggling to survive, really. So having highlighted those, there's also other challenges that the off-grid sector face when it comes to batteries, and those are regarding end-of-life disposal and management of the products in the field. So it goes without saying that the sector has done a huge positive contribution in terms of displacing use of kerosene or diesel generators, and also by giving access to energy to population who didn't before. But the sector overall is also keen not to solve a problem to create another. And one thing that has been observed is that there is a lot of inappropriate disposal of off-grid products, and often the culprits would be lead acid and lithium-ion batteries. So and second point is there's an absence of regulation overall in the sector. So there has been challenges on that front, but what we have seen is that a lot of off-grid players have had a proactive stance about this and have been working on take-back schemes, but also have been supported by funding to help them design for easier recycling, or design for repurposing, and have had access to better toolkits as well to be able to educate themselves on how to improve recyclability and reusability of their product. But ultimately, there's a key need for policy changes and for this to happen at national and international level to see a larger change. And then finally, there is a huge lack of local infrastructure. So while lead acid batteries are traditionally, can be recycled in Africa, there is currently no lithium-ion battery recyclers. And what it means is that batteries that would come through the appropriate disposal path will still have to be shipped to, say, for example, Europe, to be recycled properly and can't be done locally. So that's additional shipment and operational costs that has to be taken into account. And that brings me to the end of my section. So I will
Thank you.
Control again to Alex.
Thank you. If you don't mind, yeah, relinquishing the power of the webinar slide share. Also, Rini, we had a couple of questions come in on the Q&A. I mean, how do you feel about answering one or two questions now?
Yeah, we can do it now. That's fine.
Yeah. Federico, I think
I think the first was it's an easy clarification from Raphael, who is asking if the battery producer top tiers is defined by production value in USD, by number of cells, or by megawatt. So I think it's just a clarification on how we define the tier 1, 2, 3.
Sure. So, I mean, these are not, set in stone kind of classification, but tier 1 suppliers tend to produce batteries truly at, several gigawatt hour scale. And like I said, in terms of quality, they would be matching quality needs of tier 1 EV suppliers. So that's how you define it.
And then there is a second question, which is, I think, from Anil, who said that they have several incidences of explosion and fire-related incidents from lithium-ion batteries in the World Bank project in Myanmar. They did some investigation and related to question related to the quality of assembly, temperature, probe location were found as and specs to be strengthened, and what can be done to minimize such risk. Any preference for battery types which less risk? And before giving the floor to you, I would like to add that it's sadly pretty well known risk, fires on lithium-based batteries. A few years ago, I think last year, the WE Forum and European Recycler Association published a paper really highlighting this. And I remember in one of the biggest e-waste conference, which is annually happening in Salzburg, we always have a session on lithium-ion batteries. And the chairman of the session last year said there are only two types of recyclers in Europe, those who has already experienced a fire caused by batteries and those who will experience in the future. And that's the scale, I would say, of the problem. So maybe, I don't know if you can answer this question, Harini?
Sure, no, of course. Great question. So, I mean, the safety, in general for lithium-ion batteries is something that everyone is worried about, and it comes down to your battery so it comes down to several things. So first of all, as you said, the type of chemistry is very important. So to answer that question first, LFP chemistry tends to be the safest in terms of avoiding thermal incidents. They tend to perform slightly better at higher temperatures. They tend to be more resistant, but also when you have overheating of a lithium-ion battery, they will tend to react differently depending on their chemistry, and LFP wouldn't necessarily tend to have a big explosion. Also, the form factor of a battery matters a lot. So when we talk about a battery, you know, we often refers to a battery as a battery pack. But in each battery pack, you will have a number of cells that are being put together into, you know, modules. So it's kind of a puzzle within a puzzle. And a lithium-ion battery cell can have different shapes, and a cylindrical shape tend to be safer than, for example, a pouch that can be used. I'm not saying that, you know, pouch batteries are, you know, necessarily unsafe, but they require better management in terms of mechanical stress and pack manufacturing, which is not always, I think, which are not necessarily services that are available for the sector from what I have seen. But so that kind of answer, I guess, the form factor and the chemistry. But one thing I would say that one thing that can really affect having a thermal incident is obviously the quality of manufacturing. So what you can see sometimes is either, you know, a battery that's been badly manufactured that might have an impurity that would then lead to degradation locally in a cell. And when that cell fails, you'll have a domino effect of, you know, that cell igniting other cell, and then suddenly you have a big explosion. Or you can also have bad management. So it is crucial for a battery to have a battery management system. So if the battery is the heart, you need a brain. And it's the brain that's going to say, right, you can operate if the temperature is lower than this, if you're trying to draw current that is lower than this. And if you start operating a battery beyond that kind of window, then you're putting it at risk of something terrible like that happening. So I think it requires quite a lot of knowledge in terms of battery manufacturing, but also battery management. So I hope that answered the question.
Yeah. Thank you, Irini. And there are also other questions, but we'll come back to them later on during the discussion, because also this battery management system, we know that more and more off-grid solar companies are integrating those battery management system into their products. So it's also a nice feature, not only to know the status of your battery as a consumer perspective. I like to check on my phone what's the status of my battery, or if I need to replace, but also from a safety perspective. So I think we can move on and move to Francisca. And but please feel free to keep posting your questions because we will come back to them later.
And Francisca, feel free to ask for the power to move the slides. There we go. Approved.
I hope I get the power. Still not. Yes, yeah. I have it. I think so. Okay, thank you very much. And yeah, again, hello. I will present you today the options for end-of-life management for the lithium-ion batteries. I want to explain in the first slide, why do we have a need for recycling? So when we have a look at the market for lithium-ion batteries, we can see, as mentioned before also, we have an increased market for electronic vehicles, for example, e-bikes, e-scooters, and overall a growing market of electronic products, and therefore also an increased demand for the lithium-ion batteries. And there's also a geographical concentration of the resources of lithium, cobalt, and graphite. So the main elements in the batteries, what makes many economic countries dependent on these resources. And another concern is the environmental impact of the lithium-ion production itself. So in 2019, an estimate of roughly 60 to 100 kilogram CO2 equivalents per kilowatt hour was calculated for the NMC chemistry for lithium-ion produced, which means that the production of lithium-ion batteries is associated with significant greenhouse gas emissions. And therefore, the lithium supply security has become a top priority for technology companies in several countries of the world, and the recycling of lithium-ion batteries is therefore also an essential option to improve the circular economy and to ensure the supply with valuable materials like cobalt or nickel or something. But we also have to say that the focus of the lithium-ion recycling processes is driven by market value of the recoverable materials. For example, the cobalt and metallic fractions as the current economic drivers. And at industrial level, current recycling processes target the LCO and NMC chemistries. What Harini explained, that there are different chemistries of the batteries, both of which are highly profitable due to their high cobalt and the high nickel content. Whereas the low value of the elements comprising the active material of LMO or LFP electrodes, which is mainly manganese or phosphorus, make this recycling uneconomical. So you can see that currently not all lithium-ion chemistries pose the same interest for the recycling industry. And to manage these issues with valuable resources and batteries in Europe, the European Union brought into force the Battery Directive in 2006. And in terms of lithium-ion recycling, there are several requirements, such as, for instance, the extended producer responsibility, which means the producer must bear the cost of collecting or treating and recycling of the batteries. Or in addition, the directive also requires a minimum recycling efficiency of at least 50% by weight. And this battery directive is currently under major revision and includes, for instance, an increased collection target for consumer batteries, element-specific recycling rates for lithium, cobalt, and nickel, more specific regulations for traction batteries, because especially these get more and more, or uniform regulations for the calculation of recycling rates. So this regulation could really be a change in the battery recycling industry. So now I want to explain you very briefly a recycling process of lithium-ion batteries. This process consists of the three main steps, which are pre-processing, mechanical processing, and refinement. In the first step, the pre-processing, the spent batteries are sorted according to their type, which can be, for example, lithium-ion, nickel metal hydride, or nickel cadmium. The second step is mechanical treatment, which involves different processes applied to liberate, classify, and concentrate materials without changing their chemistry. And after mechanical processing, the material obtained is refined through a pyro or hydrometallurgy, or a combination of both. And you can see in the table on the left side a comparison between pyro and hydrometallurgy, but I don't want to go too much in detail here. I just want to show you that there are main advantages and disadvantages of the two processes, and the recycling facilities decide, on their own which process they want to choose and which output materials that they want to obtain. So if you want an economic recovery of the most important valuable components of batteries, which are so far cobalt, nickel, or copper, also in high concentration and a real pure output, which you can then use for new battery production, for example, it is necessary to do a detailed pretreatment and a pyrometallurgy to remove unwanted or process disturbing components for hydrometallurgy, because the hydrometallurgy is an extremely sensitive process. Here you can see an example of lithium-ion recycling processes. These are different ways to recycle lithium-ion batteries depending on different companies. For instance, in the middle is the Umicore process, where the batteries go directly into a shaft furnace and then into the pyrometallurgy. Other companies start with a pre-processing, where the batteries are prepared for recycling and gets dismantled or discharged, for example. And in the next steps, they do have also mechanical processing, where the batteries are prepared, for instance, a pyrolysis, and afterwards the pyro and hydrometallurgy to recover cobalt, nickel, and copper. So you can see here in the dashed lines that some processes are still in pilot scale or their industrial maturity is not proven. So I think with the revision of the new battery directive and the definition of new recycling rates for lithium, for example, that the recycling facilities get supported to develop such processes for the industrial use. And in my last slide, you can see an illustration of the global recycling capacities. So major capacities for the recycling of batteries in general are more specifically lithium ions exist in Europe, North America, Japan, or China. And currently there is no industrial scale recycling of these batteries in Africa. Instead, spent batteries are either landfilled or collected and sent to facilities in Europe for the material recycling if it is economically viable. And this brings me also to the end of my presentation, and I give the floor back to Alex.
Thank you, Franziska. That's really helpful. And I think that last slide in particular always shocks me with seeing how little is available for recycling in Africa and South America and Central America as well. Over to Federico for the final slide. Do you mind relinquishing control as well, Franziska?
No, I mean, there is also a few questions that in the meantime arrived. One is about how is lithium-ion battery repurposing facility in Africa? I mean, we know at the moment there are a couple of pilot projects ongoing under the Global Leap Fund, so funded by US EPA, which basically one company, Acceleron, which is piloting the repurposing of batteries at the moment in Kenya, with the WE Center, in Rwanda with EnviroServe, and in Nigeria with Hinkley. There are also other companies also that are doing trying to do repurposing of batteries because repurposing of battery in Africa is not only a matter of extending the life cycle of a battery, which is good, you know, in a sense, but it's also a way to avoid, to a certain extent, or postpone the huge and high recycling cost, because as Franziska mentioned, the chemistry adopted by off-grid solar sector are not the most attractive by recyclers. We did last year an investigation with some recyclers across Africa in a report we produced for NEFCO. I see Ash on the line. On NEFCO website, you can find a brief summary report, and we discussed with the local African recyclers how much is the cost for handling lithium-based batteries, including the shipment outside Africa, and we had the cost ranging from 2.5 to 6.5 euro per kilo, which is very, very high. So sometimes repurposing also a way to postpone this cost. We also had a question from Charles, who was asking, can you give a sense of how much it costs to take back batteries, ship it to Europe and recycle? I think that's a little bit the sense for the recycling cost. If you add the collection, the first mile collection and part of the disposal, you might easily add a couple of dollars. I can tell you we are currently running a pilot in Kenya with CVC and MCOPA, and we found out that consumers from rural area, they told us that it cost to them approximately $6 to reach the first place, the first shop where they can drop the device. So, you know, if you add all those small bits and pieces, I'm pretty sure you end up to easily $10–15, which compared to a retail price of a solar home system, a small one, or a kit, or even a Pico, it's really a big incidence. Can be not 1 or 2%, but maybe 10–15%.
Yeah, and this is the thing that with regulation, particularly in Kenya, emerging around how companies will have to deal with this and be responsible for all these different products at end of life management. We're going to see quite a big shift in this ecosystem, and all the off-grid solar companies are going to have to end up paying for that waste in one way or the other. And there's different ways they can go about doing that. But it's definitely a cost that will have to be factored into product prices going forward.
But let me just give a quick go through the last slide. Maybe Alex, you can just take control. I will just take the. So we highlighted the four main elements, or we call the call for action, to improve and increase the sustainability of the sector, especially when it comes to the end of life. The first one is really improving or increasing the sustainability when it comes to supply. I think Arini already mentioned in the beginning, there are more and more companies producing battery and cells that are developing processes with low environmental impact. So it would be nice if sooner rather than later, even off-grid solar sector can benefit of this kind of improvement, because if we look from a life cycle perspective, reducing the impact of producing the cells is also a very, very nice thing to have. Even if maybe a single company alone might not be big enough, maybe we can think some kind of joint or some consortia to be created for supply. The second is definitely the integration of end-of-life dimension in all access to energy program. And in the last couple of years, we've been discussing a lot with donors, with investors, and we know that investors are really, really keen and really sensible to this. I think it's important that off-grid solar company start to plan the end-of-life cost in their business model sooner rather than later, because e-waste policy, so mandatory legal obligation to collect and ensure proper recycling of their products, is coming in many African countries as well. As mentioned by Francisca, in Europe, in 2006, we had the battery directive coming. Before that, we only had the recycling of lead-acid battery because of economic reason, and a lot of alkaline and other batteries, without having an economic-driven recycling system, they were going to be landfilled. And then the Commission said we need to change this, and they adopted the extended producer responsibility principle to drive those changes. The third element is the need of proper financing mechanism. For most of the chemistry, if we leave lead acid aside, which is having a positive value, but if we look at the great majority of the lithium-based chemistry adopted and used for good reasons by the off-grid solar sector, we need to factor in financial contribution. I think here is not a matter of changing the chemical composition of your batteries to get paid at the end of life, so adding battery with cobalt. There are good reasons why you move to certain chemistries. I think here Arini can also further elaborate on that. We know that there are some companies that are looking at chemistries with cobalt to have more energy density, especially connected to new application related to mobility. So solar-powered batteries for small bikes or tuk-tuk. So those batteries might have a lower recycling cost, but a lot of other applications, they don't need such a high energy density, so they went for other chemistry. And last but not least, infrastructure are currently missing in Africa. There are good reasons, again, because they are not there yet, because you don't have enough material being collected. An investment in hydrometallurgical and pyrometallurgical facility is not small. For pyrometallurgical facility, we're talking about 10, 15, 20, 30 million euro easily. Hydrometallurgical can be less, because it's more modular, the size. but you always need to consolidate the material and channel to the facility. Now, I think it's the off-grid solar sector is starting to have some critical mass, and maybe it's also starting to, maybe we can start considering the idea of facilitating the creation of a local infrastructure to address specific needs. We know that there are countries in Africa or regions, Kenya or East Africa, where there is a concentration of products that is becoming significant. So sooner or later, maybe we can also table this discussion. That's, I think, from my end and from our end, to kind of stimulate the discuss and the debate. Now I see there are questions that are coming in, so I will try to redirect the question for the different the speakers, and we'll try our best to answer the question. I think the first one from Walter is, what's the definition of end of life of battery? I think the first, I can give an answer. The first point is that, well, when the battery is no longer used and disposed of, it's becoming waste. In the EV sector, in the automotive sector, batteries are no longer suitable for that application when they cannot keep 80% of the nominal charge. So in the automotive sector, batteries are becoming, let me say, obsolete. Well, when they still have a potential. This is one of the reasons why quite often you have repurposing of those batteries, and then you see them used as energy storage. But I would say that the definition of end of life of battery is when you dispose the battery. I think there is one question for from Jonathan, maybe for Harini. Is the EV pricing, if the EV pricing isn't realistic for off-grid solar sector, what is a reasonable price expectation in terms of dollar per kilowatt hour for off-grid solar?
Thanks, Federico. Can I just add on the previous question? I think in terms of end of life, it's when a battery reaches its end of life for one application. So it doesn't mean that it's ready to be discarded. So as Federico said, for EVs, it's when a battery has 20 to 30% degradation, and that's because the degradation in batteries tend to accelerate and kind of fall off a shoulder when it has reached that 20-30% mark. But it doesn't mean that battery can't be repurposed for an application that would be less strenuous for them. So I just wanted to add that. Just to answer Jonathan's question, so price in the for the off-grid sector. So what has been obviously, we're going based on what has been reported in public reports on this, and it tends to vary hugely from around $250 per kilowatt hour to $400 per kilowatt hour, and that's from that Shell Foundation report, speaking to several solar home systems and mini grid providers, and that's for pack cost, I believe.
Okay, thank you, Harini. We have Thomas asked, I recently spoke to a recycling company in sub-Saharan Africa who said we should be realistic about actually recycling of lithium batteries, given they can only be recycled in Europe. The cost of having them recycled would be prohibitive, and it would be more realistic in the short term to accept end-of-life lithium batteries in Africa who go to certify as hazardous good landfill. How do you see this? Well, that's a good point. I mean, we had this discussion, I think, in Berlin last year during a meeting organized by GSF. I would say that from a pure cost perspective, is definitely way cheaper. It will be always cheaper to landfill batteries compared to recycling, especially those chemistry. And we were doing this in Europe even till 5 or 6 or 10 years ago. There are 2 points. The first one is environmental, and is related to, we need to find proper landfill in Africa, first of all. So if you have a proper landfill, I would say from an environmental and safety perspective would be okay. The second element is more strategic for us as a community, for us as a society. the fact that we are landfilling, so putting under the ground material that we made some effort to dig out of the ground to refine and concentrate in products. So there is an issue of dissipation of potential resources that might be valuable again in the future. You know, there are already some studies, some activity to try to do recover material from landfill, and that could be one of the case. So being pragmatic, I think, could be a reasonable option. From a global resource management perspective, it's probably not the best one. Maybe Francisca, you also have your view on this and want to share your opinion.
I definitely agree with you, of course. A certified hazardous goods is, of course, better than landfilling on a field of something, but I think it is always better to find formal recycling which is, yeah, in my opinion, the policy which plays an important role for the end-of-life management. And there must be regulations enter into force, for example, also in Africa, to improve the local infrastructure for batteries.
Yeah, we have Anil asking, the biggest challenge in recycling, especially of grid solar in Africa, is the collection of battery, which can be spread out over a vast area of unelectrified area prior to the pre-processing. And that's absolutely true. As I mentioned already, some of the figures from the pilot we are currently which is ongoing with CDC. You can also find on the CDC website, unless we are happy to share a report that was summarizing the results of a consumer survey we did in rural Kenya, again last year. And we asked people how far they were from the easiest shop where they bought this product. And a lot of people are, 20 kilometers or more away. So that's absolutely true. And that's where we need to be a little bit creative, because this cost might be prohibitive, might be very high, especially if you say, we implement an extended producer responsibility and governments are asking producer to finance this. You have the off-grid solar sector, the industry, that is kind of disadvantaged because of the rural context of their products, which is something they are doing to help electrification effort of the government. They will have a much higher cost of take back. So that's also something that in a position paper developed together with Gogla, again, a few years ago, we highlighted. So that's where really there need to be a nice balance, because rural characteristic of grid solar, it really placing a role, placing a big burden. What is a reasonable, is asking someone without names, a reasonable life for lithium-ion batteries? 7 years, maybe this is for Arini.
Sure. Well, it really varies. It depends on what application you're putting it in and what are the environmental conditions. So if you're using a lithium-ion battery, at 40 degrees on really hard cycles, your battery is really not going to last very long. We're talking, perhaps even a couple of months. If you wanted to test this, you can leave your phone in the sun every day and see how long it lasts before you won't be able to switch it on. But if it's managed properly, it can last for 10 to 20 years. So if you think about an electric vehicle, battery pack, which is going to be in the order of kilowatt hours, that battery is going to be in that pack for 8 to 10 years, for example, and you will still have juice afterwards, just not to run an EV. So varies. If your question is more angled, I guess, in off-grid application, then I guess it depends on what you define as acceptable performance for your product. But I'd say, you could use for example, your LFP batteries probably for at least a good, 4 to 5 years if they're properly managed. And that's being quite conservative. I think you could extend it beyond that.
Okay. Thank you very much, Harini. For all the webinar hosts, so I think for each of us, kindly share your view on the following. Why lithium is preferred to lead acid in off-grid solar sector, knowing that? Okay, I can start. I said there is no there is not the best type of battery, and we got this question many times. You know, from a pure end of life perspective, the lead acid battery you have recycling infrastructure across Africa. You can get paid for a for a lead acid battery, which you say, oh, that's really a lot of pros. But of course, there is also a lot of cons. The fact that not all the lead acid battery recyclers are good, rather the contrary in Africa, and lead is causing a lot of issues with kind of pollution. It's a nasty element. Lithium batteries has been developed having more resilience to charge and discharge, and I think there is not the best option for the battery when you look at all the elements along the life cycle. So it's always a trade-off between different elements. But I'm sure that Francisca and Harini also have different opinion and can bring different elements to this.
That's more a question for Harini, but I think that lead acid batteries degrade more with every cycle. So where a lithium battery may come, for example, with a 10,000 cycle guarantee, a lead acid battery may peak at 2,500 cycles, for example. So that's my point why I would choose the lithium battery, but I think Harini knows that a little bit more.
No, I think that's a very valid point. What I would add is, so I can see Rafael has posted other comments below as well. So lead acid is cheaper per kilowatt hour. So there's kind of yes and no, I guess, if you have to consider usable kilowatt hours. So one of the great advantage of lithium-ion batteries is you can have a better depth of discharge, meaning that, you know, if you have a battery that's fully charged, often people think that, you know, you use all that capacity and you don't. You always have a safety reserve because having a reserve essentially just help the battery last longer. So while that reserve might be, you know, around 20% for lithium-ion batteries, actually for lead acid batteries, you don't want to cycle it deeper than 50% really. So actually, in terms of your battery size and usable capacity, I'm not sure that lead acid is necessarily always cheaper. So, and of course, there's the cycle life issue that Francisca pointed out. So and I agree that weight is not necessarily always an issue, although I do think that, you know, if you want your solar home systems, for example, to be easily repaired and therefore need to be moved about, you know, if that customers needs to bring it to shops, that's not always easy if you have a really bulky system. So that's also something to have to consider. And I think that's all.
Yeah, thank you, Harini. I think.
So we had some questions that were posted into us in advance of this webinar. So I'll just to break it up, mention one or two of those. One's for you, Francisca, which is it's around the sort of different metals that can be recycled at the moment. So currently we can recycle metals like nickel, copper, and cobalt out of batteries. But what about recycling lithium and graphite content? Is that possible now, and will it be possible in the future?
So basically, there are currently some facilities that can recover lithium from end-of-life batteries, but so far only on a laboratory scale. I know from Umicore they do this lithium recycling, but yeah, not in a large scale. And graphite isn't at the moment a focus in today's battery recycling plants. Recovering lithium from the slag is very energy consuming and therefore also expensive. And at the moment, it's not yet economical for the recycling plants to recover the lithium, as well also the graphite, as the price for the primary raw material is much lower than the secondary raw material. But if we think about the future, the decreasing availability, for example, of lithium resources will also increase the price and thus make recycling more economical. And what is also a driver, at least in Europe, with a new revision of the battery directive, which will also change a lot, especially the recycling rates are defined for lithium, and the recycling plants must comply with this. And in order to achieve this, the recycling companies gets more supported, for example, in projects that investigate methods for recovering lithium. For instance, we are working together in a project with a battery recycler, and they are still working on developing a recycling process for lithium because they know that the directive will change a lot. And so it is not yet possible on an industrial scale, but I think that it will be in the near future.
Okay. Well, that was an optimistic finish, at least. Excellent. I've got a question here also for Federico that was sent in, which is it's a good one, actually, because I know this is a bit of an existential concern. Should concerns over proper end-of-life management slow down the pace of adoption for off-grid solar solutions?
My answer would be a big fat no. Like for those watching, the X Factor here in the UK with Simon Cowell, I definitely think no. It's a really a big and bold no, because we know that there are massive benefits with the off-grid solar sector, and it's really changing life of a lot of people. And I'm, as a background, mechanical engineer, so I like to do things, and I'm positive. And I mean, we know that technology and there are processes that are being developed. What we need is really to make sure we build the system, we create this safety net at the end of life. So that's, I think, why we should not slow the pace of adoption of end of life of off-grid solar solution. We just need to increase the pace of solution for the end of life. That's my point and my recommendation.
Thank you. And lastly, there's a question here for you, Harini, which is on sort of advances. So what are the most promising technological advances in the battery sector for off-grid applications in your eyes?
Great, thank you. So I think we hear a lot of different type of batteries and new type of batteries and improvements on lithium-ion batteries in the press, and especially nowadays you see a lot on fast charging and solid-state batteries and sodium-ion-based batteries. And all of these technologies are really promising for the for the battery sector as a whole. But you have to keep in mind, from discovery of a new technology at a lab scale to bring that to commercial level, we're talking, several years worth of journey, and then to bring it up to at scale production, that add on a couple of years onto that. So I think, out of those new emerging technologies, perhaps sodium-ion technology is the most promising because it promises to be really cheap, and sodium is a chemical that's widely available. But I think we're a good, decade plus away of that being available for the sector, because to be, frank and honest, I think the off-grid sector doesn't have the mean to be the early adopters of any new technology, because there's only going to be, niche manufacturers, and therefore it's not going to be cheap. But also it means that off-grid players will have to tie themselves to one or two suppliers and put their own production at risk. So I think we're quite far away from that kind of new chemistries emerging. But what the off-grid sector really would benefit from in the short to medium term is this learning from other sectors, whether it's larger stationary applications or the EV sector in terms of battery management. So how do you manage your batteries in the field in a smarter way without having to add necessarily loads of tech on the hardware side and therefore increase the cost? And how can you optimize the lifetime of a battery in its first application, whether it's in a mini grid or in a solar home system? And then can you repurpose that battery for a different application? And I think that those discussions would come more and more, and we see that with second life batteries coming back to interest. And I think for a long time, they're considered as, well, it would be nice, but it's too expensive. Whereas now, with more EV batteries being discarded globally, being able to repurpose those for other type of, lesser kind of energy demand applications, such as off-grid sector station application is coming to play. So yeah, that'd be my answer.
There is a quick one also probably for you, Arini. Is there any some lithium battery pack supplier in Africa? I mean, cell assembly. Are you aware?
So that's a good question. So no major one that I'm aware of, to be honest. The only one I know who kind of assemble packs, but not so purchase cells from elsewhere, but assemble packs locally, might be, as you mentioned, Federico, Acceleron, who repurpose discarded second life cells and put packs together. But there is no pack manufacturers, as I'm aware of. I know there is quite a lot of press in South Africa with wanting to manufacture their own cells and packs, but I haven't seen anything at scale yet. Yeah.
And then we have Vincenzo, who is asking, consider the most of the market of off-grid solar products in Sub-Saharan Africa is informal, not taxed, not regulated. Should we really rush into adding costly and difficult to implement recyclability taxes that would result in reducing competitiveness for the formal business versus informal and more expensive products for low-income off-grid households, which is a very kind of, I would say, crucial question. I mean, first of all, my answer would be the fact that a lot of products are smuggled, are not certified, has nothing to do with the end-of-life management. That's a matter of making legitimate companies doing business and stopping the others. Of course, the end-of-life dimension will add a cost. That's out of question. But there are two elements that I think we should consider. First of all, I think it's a matter of being responsible and considering the impact of the product that a company is producing. It's not that we just put the benefit of getting light to people or energy to do. It's also a matter of preserving the environment they live in. Having a fire in a village in a rural area is not nice. And then I think also that most of the countries are anyway developing end-of-life policy for electronic products, and off-grid solar will fall under the scope of most of those policies. So I think it's a matter of being proactive and maybe develop and ask for the right mitigation, because it's clear that off-grid solar companies have some disadvantages when it comes to collection and recycling. And those should probably be balanced with the extra benefits that those companies are providing to countries when it comes to access to energy. So for me, it's a matter of finding how to best share those costs among stakeholders in the system. Maybe there is a question very technical about thoughts on from Akini, talks on refurbishment of lithium-ion batteries and reports on sand batteries being battery technology rumored to replace lithium-ion batteries. I think maybe, Harini, you did a little bit answer this, but if you want to add something.
No, I mean, I have nothing to add to that other than I think a lot of the things that are being reported are actually much earlier stage than you think it is. I think for the next 5 to 10 years, lithium-ion batteries are very much going to run the show, and that's most sector-wide, so not just the off-grid sector.
Okay, we have a question from Christopher. How much greater is the financial incentive to recycle NMC rather than LFP in remote areas? Should this inform initial battery choice? Well, the logistic cost, I would say, is the same. What is different is the cost of recycling. I think for both the chemistry, you don't have a solution in Africa at the moment, and so you need to import those batteries in Europe or in other countries, like Francisca mentioned. And maybe, I don't know, Francisca can give you a little bit of insights on how recyclers, battery recyclers in Europe are pricing the different battery types. Maybe can give you a little bit of information around that.
I'm sorry, not so much information, but what I know is that the disposal fee always go with the market price of the materials. So for example, the copper or cobalt price. So the recycler always adjusts their fees regarding the market price, and cobalt or copper is much more expensive than phosphorus or manganese, for example. Why these NMC batteries more interesting for the recyclers than LFP, for example. So that's the difference of the cathodes.
Okay, we have Antinen. Sorry, sometimes I mispronounce your names. I missed something due to connection problem. What is your recommendation lithium-ion batteries management, either recycling in Europe or repurposing in Africa? Which one is the most cost effective? Well, I think if repurposing in Africa it's possible, that's probably the way to go. At certain point, even repurposed battery will reach an end of life. So ultimately, you need to have recycling. If you don't have recycling in Africa, you will have to do recycling in Europe. That's or recycling in Europe. There are some development in India as well, or well, North America. I think is too far anyway. So I think repurpose, if possible, repurposing is always preferred. Even from a waste hierarchy perspective, is better because it's extending the life of the product. So repurposing is always better compared to recycling as a first option. Maybe I don't know if Arini, Francisca, have anything to add on this. Okay. We have Elizabeth, who is asking, for off-grid solar distributor companies, what kind of policies or selection criteria should companies have in place as they look at sourcing for lithium-ion batteries, while considering the challenges in recycling or safe disposal faced in Africa? Top 5 things to look out for. Well, I think how you source the battery doesn't really impact the recycling cost. I mean, the chemistry, of course, is as we already explained, it's having a role. So, but excluding that part, probably you just need to make sure batteries are good quality because they will last longer, so will generate less waste. From a pure legal perspective, the company you source the batteries or the cells from are not necessarily seen as the producer. You will be responsible for the end-of-life management in most of the countries. But if it's not the case, you need to make sure something to check is whether they are registered and responsible for the financing of the end-of-life management of the battery, if you're importing batteries as a standalone element. I think Anil also put the question, what are and how serious health and environmental damage from improper disposal of such batteries that justify collection and recycling? Well, I think depends on the chemistry of the batteries. For lead acid batteries definitely have a much higher implication in terms of damages that pollution from lead causes on the people, on the pregnant mother, on the fetus. It's really impressive. If you look at WHO reports, the effect of contamination from lead, and we know because our friends from Eco Institute did quite some work on this. You test the blood level, you test the lead in the blood, the level of lead in the blood of people living close by to informal lead recycling, you find the value of lead which are hundreds and thousands of times higher than the maximum limit defined by WHO. So lead is really bad in that respect. For lithium, you might have other risks, maybe related to fires, which are also not negligible in rural Africa, and especially when you don't have a lot of water close by, or other measures to kind of extinguish the fire. But here, Arini, Francisca, feel free to add if you have other kind of perspective on this selection.
Maybe I will add that, of course, improperly disposed batteries contribute also to water and air pollution. So when you're putting on a landfill, the batteries, they corrode, and the chemicals, of course, can leak out of the battery and then contaminate the groundwater and surface water. And also the toxic chemicals can release into the air and negatively affect our breathing and contribute also to global warming. So recycling is always, a better way.
And I think, as I said, I know it's a concern for companies because it's a cost, and I fully appreciate and understand that. And I'm not here to say that it should be companies' role to just pay for that. And I think, for me, there are very good reasons to discuss how this cost could be cross-financed or kind of offset by the benefit that you guys, if you are off-grid solar sector companies, are generating in terms of access to energy. Because, we can also say that part of the saving of electrification of rural area, which is a lot of money that the local governments are saving, maybe should go and cross-finance proper recovery of material from rural area. And this, for me, would be a very good argument and thing to put sooner or later on the table. But before moving on also with other question and answer, we would really like to get a feedback, a very informal feedback from those of you that kind of, you all almost stay all here, only a few had to leave earlier. Would like to get a little bit of your rating of honest rating of this hour and 20 minutes we spent together.
Yeah, exactly. Yeah, thank you so much for attending today, guys. And we're doing our best in the remote working world to keep this a interesting and, as I said, compact webinar, so you don't all feel like you just clocked into a different world for 3-4 hours. If there's any questions, I think most of you have our emails, but we're happy to share those as well, and I'll put them in the chat. And just type if you want the recording. I know lots of you put your emails there already about receiving the slides. I can share the recording as well. So just
it will miss the first 2 minutes, but
yeah, I made a little error at the start. I was a bit frantic. I recorded about 3 minutes in, so it will just cut nicely into the meat of the topic.
But feel free to vote. We cannot vote, so we are not.
Yeah, we cannot. And so far, no one says it was a regrettable experience or a highly average experience. So that's good. Good to hear. Success.
So please vote before disconnecting. And of course, if you have other questions, you can always reach out to us. We are more than happy to keep this conversation ongoing. You might be aware we are still working on different topics and projects in this space, but we are really happy to engage further with some of you. Sooner or later, we will also maybe be able to meet in person somewhere. And in the future also we organize similar event in kind of face-to-face, because of I think most of you are in different location. I think the virtual will still play a key role, but I'm pretty sure in the next Off-Grid Solar Expo organized by Gogla, we will be there, and in other occasions we will try our best to be present. So.
Yeah, well, thank you very much, everyone. Yeah, our emails are there in the chat. We will go quiet now, but it's been a pleasure to see you all here today, and speak soon.
And thank you, Arini and Francisca, for your support in this event and also in preparing the white paper.
Thank you very much.
Happy to support.
Thanks, guys.
Thanks. Bye-bye.